Hello, didn't see you there. In this short video, we're going to be talking about the operating system that runs this beautiful little chip. This is called the ESP32, designed by Espressif with the express purpose of being used in Internet of Things applications. It uses very little power, can be easily integrated into a printed circuit board, has got plenty of input-output pins, as well as a Bluetooth/Wi-Fi radio, the antenna of which you can see sitting above the dev board here. Now, it's a system on a chip, which means that it's got a lot of the components of this Raspberry Pi, all within something the size of 5 cents. The actual chip, less all the peripherals, is that little metal box with an R on it right there. So what's the operating system that can actually provide all this fantastic hardware? It's got a dual-core processor, it's got an ultra-low power coprocessor, 512 kilobytes of RAM, peripheral interfaces, hardware acceleration, flash encryption, power management, and a random number generator. Well, that operating system is called the Free Real-Time Operating System, which is an open source project that you can take a look at. So a real-time operating system provides one guarantee, and this is how it's different from other operating systems like your Windows or your Unix operating systems. And that one guarantee is that an event or task will be processed before a specific deadline. So for example, there'll be a real-time operating system in your car that will promise to inject the correct amount of fuel into your cylinder before the cylinder rockets up and compresses it, and thereby not damaging your car. If it missed that deadline, it would have been in all sorts of strife. And that's what a real-time operating system is really used for. These very deep embedded systems where you may not actually see the software itself. But how does it maintain this deterministic property? Well, the FreeRTOS uses a deterministic, traditional, real-time, multitasking scheduler. And we're going to unpack that in a moment. But what it really means is that all these tasks are given a priority. And tasks with the highest priority that are ready to be run will be run, while the lowest priority tasks will be suspended. Now, we're going to use an example here of 3 different tasks. The first task, a control task, must be run every 2 milliseconds. And this, for this example, is going to be a signal sampler. The second task is a keyboard handler task. And what it does is that when you press a key on a keyboard, it will be processed within 100 milliseconds, and that's its deadline. And finally, we've got the idle task. The idle task is a task that's actually created by the operating system, and it is entered into when there are no other applications left to run. So how does this actually work? So whenever a task of higher priority is ready to be executed, the scheduler will preemptively suspend execution in the current task. It does this by using a interrupt service routine where the current context, i.e. the registers and the flags, etc., of the current task are saved, and then execution is switched into the higher priority task. Once this priority task is completed, execution is returned to the scheduler, and the scheduler will then decide what is the next highest priority task to complete. There are 4 states that the scheduler will recognize of tasks: suspended, ready, blocked, they're all the not running states, as well as running. You can see the different function calls that FreeRTOS uses to actually change the state of these tasks, and so on. And now some of these function calls will actually happen within the interrupt service routine itself, which is this little diagram here. That's all I've got about time for. So take a look at this diagram, but I'd really like to talk a bit more about Richard Barry's book for a quick second. Which is a great resource if you'd like to learn more about the FreeRTOS. And I really only talked about task management here, and he goes on to a lot more. The other thing to note is because ESP32 is a dual core processor, whereas FreeRTOS is really only a single core operating system, it's actually had to be extended so to manage symmetric multiprocessing, whereby each of the individual cores can actually hand off processes to each other and also have their own independent schedulers. In any case, that's all I've got time for. Thank you.